Let's begin. Today's May 14th, 2024, and we're doing the Daily Turing Machine Puzzle. Notice that today's puzzle uses 6 criteria cards and the 6 verification cards. Let's go to turingmachine.info to get more information on today's puzzle. So today's puzzle uses the criteria cards 2, 6, 13, 18, 19, and 20, and also uses the yellow or orange colored verification cards. Let's go solve. So in our grid above, we have our 6 criteria cards. On the top row, we've got criteria A, criteria B, and C. In the bottom row, we got criteria D, criteria E, and F. So criteria A looks at the first digit, the triangle digit, and compares it to the number 3. Is the triangle digit supposed to be less than 3, equal to 3, or greater than 3? Criteria B looks at the middle digit, the square digit, and will let us know whether that digit is an even quantity or an odd quantity. Criteria C will compare the middle digit and the last digit, the square and the circle, and basically let us know whether the square should be less than the circle, should they be equal, or should the square be greater than the circle. Criteria D will take the sum of all 3 digits and will let us know whether that sum is an even quantity or an odd quantity. Criteria D then looks at the first 2 digits, triangle and square, takes their sum and compares it to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria F will look at the whole code and will let us know whether there should be no repetition, basically meaning that all digits should be unique or distinct, as in the example 1, 2, 5, or should the whole code have a pair of duplicate digits, as in the example 1, 1, 2, or thirdly, could the code actually have a single digit repeated 3 times, as in the example 2, 2, 2. Remember, our objective is to find that one unique code that meets all of the criteria we just described. And as a first proposal, I've chosen to use the digits 3, 1, 4. Okay, so I'm going to first test criteria B. I always like to figure out if one of those digits is even an odd or odd and eliminate the numbers that don't conform. So let me test B. Okay, so B, the Turing machine tells us it is incorrect. So if I look at my proposal and I'm looking at square, I chose 1, which is an odd. So that the Turing machine is basically telling me no, that middle digit should not be odd. So I'm going to go into my notes for criteria B and state that the square is an even digit. Since it didn't like my 1 and it's odd, it's letting me know that the square digit should be even. So I'm going to go up here and eliminate all of the odd digits for square. Okay, fantastic. And as I observe the remaining criteria cards, I think I'll test criteria D, which takes a sum and lets us know if it's an even or an odd quantity. So let's see what criteria D tells us. Okay, so that is also incorrect. So let's see, if I go back to my proposal and I sum up the digits, 3 plus 1 is 4, 4 plus 4 is 8. That is an even quantity. The Turing machine is letting me know, no, the sum should not be even. In fact, the sum should be odd. So let me go ahead and write that down in my notes for criteria D, that triangle plus square plus circle plus circle is an odd quantity. Is equal to an odd. So again, my proposal summed up to be even. The Turing machine did not like that, so that's odd. Okay, so can we determine anything about the code in general? Well, remember that we already discovered that the square must be an even digit, but the sum of the three digits has to be odd. So that means that for that to happen, I would need to have another even and an odd. The reason is, if I add up those two evens, that sum is an even, but I need an odd digit for the sum to be odd. So in addition to this, I will say that of triangle and circle, one is odd. Okay, so the implication is that the other's even, but I do need one of those to be an odd digit and the other one to be even. Again, two evens added together is an even, and then an even plus an odd is a total odd. Okay, so that doesn't really help us eliminate anything, because at this point we don't know whether triangle or circle are even or odd, but at least we have a general idea. Okay, so since we do have two evens and we do have this criteria card letting us know that, either there's no repetition or there is a pair, let's see if what that'll tell us. So that is criteria F. And so, okay, so that is correct. So if I come back to my proposal, notice that my proposal of 314, they are all distinct. They're all unique. There's no duplicate digit. The Turing machine confirms that that's what it should be. So that means that for criteria F, I'm going to write down that all digits are unique. Okay, and so what does that mean? Remember, we do have two evens, right? We know that square is even, and one of either triangle or circle are also even. If they are unique, that means that I can't have a duplicate even digit. So that means that I'm going to put down here that the digits are two and four and an odd. Okay, so the fact that they are unique lets us know, and because we have two evens, that they can't be paired up. It's got to be two and four, and of course we have some random odd somewhere. So so obviously we know that if square is 2, either triangle or circle has to be 4. If square is 4, then triangle or circle has to be 2, and of course the other one's odd. So that'll help us sort of come up with our second proposal, since we already completed our 3 Turing tests. Okay, so what haven't we done? We haven't done triangle, which compares it to 3, which is a good indicator. If it was an even, but again, we don't know for sure. 2 is less than 3 and 4 is greater than 3, so that would be ideal. On the other hand, if we knew it was exactly 3, then we know circle would be the other even. So that's helpful. Criteria C compares our square and circle. Again, we do have this 2 and 4, so that could potentially help us get closer to our code. And then we also have this sum. Okay, so out of all of that, what can we come up with as our proposal? We could try to... Oh, one other thing. So coming back to this criteria E about the sum. Since we do have an even digit and square, that means that, oh wait, no. We do have an even and odd. Okay, never mind. I was about to say something about 6, but no, that wouldn't be true since I don't know whether triangle is even or not. Well, since square is 2 or 4, the only way that the sum would be equal to 6 is if it was a 2 and 4, which potentially could work out if it were 6. And then depending on what square is, that may help us figure out what the odd, potentially odd digit of circle would be. So again, we're always trying to force the issue. So for example, if square were 2, we could potentially force it to be a 1. If square is 4, we could potentially force a circle to be 5. So maybe that is a good strategy. And then we'll let blue let us know which even it is. Is it greater or less than? The question that's still kind of lingering is, what makes triangles, well, the sum would make it into an even. That's what it would do. Okay, so let's try that. So let's try 4, 2, 1. Let's see, that could be a potential. 4, 2, or 2, 4, 5. Yeah, so let's do 4, 2, 1. 4, 2, 1. Okay, so since it was the sum that kind of led us to this proposal, let's test criteria E. Okay, so it is not equal to 6. Okay, so that was criteria E, and the sum is not 6. So in our notes here, we'll put down triangle plus square is either less than 6 or greater than 6. And the good thing about that is, okay, since it's not a 6, that means that triangle has to be odd, right? Because again, the only way we could have gotten 6 is if triangle were even. Since it's not equal to 6, that means it must be odd. So let me go up here in my notes and eliminate all the evens. Okay, so that means this is odd, which means that circle has to be the other even. So I'm going to eliminate all of the odds. Okay, and so here we have our odd, even, even. Okay, and so let's see, what can we test next? Okay, so this will be a good test, criteria C, because it'll tell us the order of the two evens. So let's do C. Okay, so that also failed. So let's take a look at our proposal. In my proposal of 421, I have square being larger than circle. The Turing machine disagrees with that, so that means that square should be less than circle. Remember, it can't be equal since we have all unique digits. So that means that square has to be less than circle, and that was C. So we're going to say square is less than circle. And of course what that means is that we know that square has to be 2. So I'm going to cross out the 4. And I'm going to cross out the 2 for circle. And so we have triangle we don't know just yet, but we know that square and circle have to be 2 and 4 based on this last test that we did do. Okay, so can we somehow deduce the answer without testing for A? No, the only thing we know for sure, well, okay, so we do know something about the sum. Well, we know that it's either less than or equal, or sorry, less than or greater than 6. Well, since it's a 2, yeah, we still, okay, here we go. Let me come down here and start listing some potential answers. Okay, since we know that, of course, square and circle are 2 and 4, triangle can be a 1. So one potential answer is 1, 2, 4. Or it could be 3, 2, 4. Or 5, 2, 4. Okay, so if we look at 1, 2, 4 and 3, 2, 4, both of these potential solutions have a sum that is less than 6. Okay, so it conforms to the possibility of the sum being less than 6. Observe that all the sums are odd, so that means that D is okay. We already sort of confirmed what square and circle are, that had to be squares less than, which all of them are. We do have that middle digit be even. Okay, and they're all unique, 1, 2, 4, 3, 2, 4, 5, 2, 4. So the reason I want to highlight 1, 2, 4, and 3, 2, 4 is that, well, no, I take that back. Well, they do all sum up, but yeah, so, nope, yeah, never mind. I thought those were ambiguous, but triangle will let us know. And unfortunately, we really need to get lucky because, it's 1 out of 3 randomly. And so I may actually have to test it twice. Okay, so let's go ahead and test A. Let's hope that it is greater than 3. It is not. Okay, so we know that triangle cannot be 5, 2, 4. Oh, this is difficult. Just because I didn't want to go to a third proposal. Okay, so I'm going to choose 3, 2, 4 as my third proposal. And again, I am forced, I don't see any other way, I am forced to test it again. All right, so let's test A again. And that is incorrect. Okay, so in fact then, triangle has to be less than 3, and of course the only digit left that's less than 3 is 1, so that would be 1, and based on all of our other conclusion, square and circle are 2 and 4. Okay, I really didn't want to test A twice, but it was unfortunate. Okay, so I'm proposing that the solution is 1, 2, 4. So let's go to the Turing machine and see what it says. So we're going to test the code, and it's 1, 2, 4. Verify. Okay, we got it. But again, the true test is, did we beat the Turing machine? So let's go back and see, what did I check? So I did BDF first. So BDF first, and I believe the F criteria was the only correct one, yes. And then I did ACE, and they were all incorrect. In the second round, I did ACE. And of course, at last proposal, I checked A twice. Let's see how we did. Okay, wow, I am surprised, pleasantly surprised. We beat the Turing machine by 1 question. Obviously, we did it in We both did it in 3 rounds, but we beat it by 1. I am totally surprised, but elated at the same time that we beat it. Okay, well, that does it for today. If you like today's video, please give it a thumbs up. If you don't want to miss out on tomorrow's puzzle, make sure to subscribe and you'll be notified of when that video becomes available. Again, that's it for today. Thank you. Have a great one.